And I consider simplicity to be probably the most important lesson I have learned in my about 11-year career as a developer. It's nothing to do with design, I mean UI design. It's nothing to do with how things look or how easy they are. Simplicity is actually quite a complicated aspect, and it needs explanation unless you are already exposed to it, which I assume most developers are not. And yeah. Well, I also send, aš dar PDF failą siunčiu tokį. Tenais jis buvo eksportuotas. Arba galit, arba yra linkas tiesiai į Google šitą drive, tenai ta prezentacija yra. Okay, I'll just keep talking anyway. Yeah, and some of the topics I talk about may seem a little bit controversial to you. If they do, bear with me, because those ideas are something that we truly believe in. I mean, me and my colleagues, we apply them in our daily activities. So it's not just a theory. Okay. The first slide is not that important, so it just may be there. My presentation is mostly based on ideas of Rich Hickey and Dan North and other people as well. You may have heard of them. Dan North is of BDD fame, and Rich Hickey is the inventor of Clojure, programming language, and Datomic, and other things. It's not an original idea, and their ideas were also not original. You can trace them back to Dijkstra and probably to ancient Greeks, if you want. And the idea is this, that the simplicity is a prerequisite for reliability. So if you want to create something that's reliable and maintainable and agile in the core sense of this word, you have to be simple. And it doesn't matter what process you use. Once your system reaches a certain level of complexity, you won't be able to change it as fast as you were. So you won't be as agile as you can be. And this is core to our understanding of what simplicity is. I'll just use these for now. Okay, I skipped this. This is really weird. It's not. Yeah, how do I at least make it fit into the screen? So this is Dijkstra, and he said that computing's central challenge, how not to make a mess of it, has not been met. Well, it's better, I guess. It still doesn't quite fit. And he's right. It's a good example of using double negative in the same sentence. But still, he's right. I mean, he said that like 33 years ago, and well, it was like ancient times. Now we're not like that, right? We're building robust systems, and we're not making a mess of it, and it's all good and nice. Well, my practice shows not quite. Most projects I worked for ended up more or less like a mess, even though they considered themselves to be agile. So what's the problem? The problem is the way we understand simplicity. I mean, everyone agrees that simplicity is important. We need to build simple systems, but many people have different views of what simplicity is. And they mainly they confuse simplicity with things like familiarity or convenience. If you use a tool and you know how it works, it's easy to use and you think it's simple, although it can yield immense complexity. It's nothing to do with small or concise. You know, if a line of code is really short and really small and looks nice, it doesn't mean that it does not yield complexity. Also, simple does not mean beautiful or elegant. It's completely subjective what is beautiful and what is elegant. So what is simple? Well, if you take MacBook Wheel, you know, it's a fake product. It wasn't really built, but there was a commercial, maybe you've heard of it, of a MacBook that has only one button. Is it easy to use? Well, it looks easy to use. It's only one button. Is it familiar? Yeah, we know what Mac is. Is it convenient? Is it beautiful and elegant? Of course it is. Why is it simple? The tagline was, which is up there on the screen, you can't read it, so I'll read it for you. Nothing is more simple than a giant button. It's not true. A giant button that does many things is not simple by definition. It cannot be simple. How do you send a email message with it? I mean, you start to discover complexity once you start to go beyond the interface and into how it works, actually. And that's where complexity creeps in. Contrast that to... There's a slide missing. Oh, shit. It's the wrong version of the presentation. Where did you take it from?
It's last what we get.
No. I believe you took it on Monday and exported it into PowerPoint, and it's that version. Sorry for the inconvenience. Okay, I'll talk about the slide which is not there. Contrast that to a Boeing cockpit. Now, Boeing airplane cockpit, which has hundreds of buttons and switches and indicators. That looks really complex, although each button does one thing, and each switch turns on one thing or off, and each indicator conveys exactly one piece of information, and therefore, by definition, it is simple. Is it easy to use? Well, hell no. If you are training to be a pilot, a Boeing pilot, then it's very hard to use. But once you learn how to use it, it becomes simple. Imagine what it would be like if a Boeing airplane had one button to launch the plane, like you sit in and you press the button and you lift off. It would be really easy, but it would yield immense complexity. What if you press the button and, I don't know, one of the engines don't work, or the doors don't shut as they should? There are a million reasons it can fail, and there are a million reasons controlled by those individual buttons and switches. You do the sequence, and at some point it fails. You know exactly why it failed, because it's simple. When you have one button, it's a black box. You have no idea why it failed. How do you fix it? I don't know. So that's to get started by what simplicity is and isn't. It's not as easy to comprehend simplicity as you may think. Now, Agile principles, which are 12 of them, anyone has read the Agile principles? I don't mean the manifesto, but the principles behind the manifesto. There are 12 of them. And one of them mentions simplicity explicitly, and it says simplicity is the art of maximizing the amount of work not done, which is just bollocks. I mean, this is wrong. Simplicity is not about minimizing the amount of work done. It's Yagni, right? Hello. Something is utterly wrong. Hey. Yeah, it's Yagni. You ain't going to need it. If you maximize the amount of work not done, you're optimizing for Yagni, which is a good thing, but it's not what simplicity is about. It assumes that all you need to do to have a simple system is to not put complexity into it. And it's not how complexity works. Complexity is an emergent phenomenon. It emerges like entropy, the moment you stop paying attention to it. It emerges naturally. Unless you take certain steps to reduce complexity, it will bite you. So, fortunately, there are other principles in Agile Manifesto which also talk about simplicity, although not explicitly. One of them is change. Harness change for the customer's competitive advantage. This is a good thing, of course, but what does change mean? Change does not mean changing requirements only. It does not mean change requests. We do change our software each time we implement a new feature. We change it each time we fix a bug. And we need to be able to make those changes in the short run and in the long run as well. And what does it have to do with simplicity? Well, simplicity enables change, and complexity kills it. This is a Russ Miles quotation. He said, "Complexity is the silent killer of delivering the right software or change at the right time." So if you have a complex system, you won't be able to change it fast enough. Another principle talks about design. Technical excellence and good design enhances agility. I thought Agile was all about throwing the design out of the window, wasn't it? Like, we don't need design, we don't do architecture, we just code, we iterate. Well, if you don't explicitly do design, you still do design, but you don't think about it. And most likely it's not a good design. Design decisions are made each time you create a programming artifact, like a class or a function or a method. When you think where to put new functionality, how to split things apart. Design is about taking things that look complex and split them into separate components, which are simple. So you do design decisions all the time. And if you have good design, then you're agile. It's as simple as that. Of course, you still need to have an agile process, but this is the core of agility. Good design is simple design. Why? Well, there are 4 rules of simple design coined by Ken Beck, and those are: design is simple if it passes all tests, it contains no duplication, it uses meaningful, clear, and consistent names, and it's minimal. Those 4 rules. And Martin Fowler has said that design is there to enable you to keep changing your software easily. So design accommodates change. Last thing, developers should maintain constant pace indefinitely. Well, that's a catch. So you can do change and you can have design changes, but you don't always do that in the time constraints that you have. I mean, if you want to keep implementing the same amount of functionality and doing change in the long run as you do today, you will need something simple. If you have complexity, as Rich Ike has put it, sooner or later complexity will dominate what you can and cannot change, and how fast you can change it. Okay, so from what I have read, I have come to ultimate definition of simplicity, and it is, there should be a drum roll here, no? My ultimate definition. Please welcome. Yay! Now, it doesn't sound incredibly complicated, but really, simplicity is there where there's no complexity, and now all we have to do is to define what complex is. So let me start over. Hello, my name is Osvaldas, I work for Inventi. I'll talk about complexity. There are several artifacts or aspects that yield complexity, and I would like to very quickly mention them. One of them is mixed responsibilities, when you have a component, an artifact, a class, something like that, and you put more than one responsibility into it in such a way that they cannot be reasoned about separately. You have just complicated things. You have made it more complex. And that's bad, because when you need to change one of these responsibilities, and you will need to change it sooner or later, you will also touch the other one, and you won't be able to reason about the one without reasoning about the other, which will put mental strain on you, and you will make bugs. The other aspect that yields complexity is coupling and dependencies. The more direct dependencies you have, the more complex your software is. On the diagram, on the picture on the left, there is a server room, and I would not like to work there. Suppose you are a system admin, and you are asked to move one server from place A to place B. What do? Well, you cut all of the dependencies, you move the server, and then you reconnect all the dependencies in such a way that everything works as before, right? How easy it is to do. The more dependencies you have, the harder. On the right side, you have another server room, which probably has the same amount of dependencies overall as the first one, but there's less direct dependencies. Components are not interlinked with each other in arbitrary ways. They are very clearly isolated. So it's really easy to move things around, and that's called change. If you're working on a system like that, it's easy to change. Now there's one subtle state, subtle kind of coupling, which is called state, or mutable state. You know probably what it is. If you have some component in one part of the system that can change its state over time, and you have a reference to this component in another part of the system, these two are complicated together. They are bound in such a way that you must think about both of them at the same time. You cannot isolate them. So there's a dependency, but you cannot see it. It's implicit in the design. And state causes side effects, like in this diagram. We have quantum entanglement. Quantum entanglement is a phenomenon where you complex two particles and then you separate them. And by collapsing the wave function of the one particle, you immediately change the other one. It's a weird phenomenon, but it happens in nature. So that's what happens with state. So you cannot think about one particle without also thinking about the other one. And reasoning and thinking all puts mental strain to our brain, which is a bad thing because we have to reason about the software that we create. We have to be able to look at the code and understand what it does. And when we want to change it, we don't want to go around all the dependencies and all the responsibilities and all the implicit dependencies that are there in order to make the change. If we have to do all these additional things, we have incidental complexity. So I'll talk about that really quickly. There is essential complexity, which is domain complexity, which you cannot do anything about. If you're working for insurance, I mean building software for insurance, you inherit a complex domain. So you cannot simplify it because insurance will not become simpler. All you can do is take that domain and split it into smaller pieces and design those in order to bring your understanding closer to the domain. You cannot simplify it. But my practice and practice of many other people shows that what we often do, we wrap this essential complexity with enormous amounts of incidental complexity. Incidental means it doesn't have anything to do with the problem domain. It's only there because someone put it there. It doesn't solve the customer's problem, but it's still there. So why do we do that? First, it's there in your code. So each time you create a strategy factory registry configurer, it's an artifact that doesn't contribute to the problem domain solving, but it's there because you put it there. Each time you use libraries and frameworks which are complex, and you only use a small piece of that, but you still bring all the complexity that doesn't help you solve the customer's problem. It's incidental. And in the base, there is the language, the runtime and environment, which also has its own complexity, which is more likely incidental than essential. I may skip these. How much time do I have? Okay, then I will not skip these. Yeah, your code may be complex, but you may not know that because you have all the IDE support to help you ignore the complexity. For example, refactoring is great, but if you rename a class and you see your Git diff, and 200 files have changed after that rename. What does that mean? It means you had 200 dependencies, and you changed all of them. So your code was complex, but you didn't notice, because the tool was there to help you ignore it. So you should keep that in mind. Auto import is also, my class has 100 dependencies, 100 classes it imports, but I don't see them because I just auto import them, and I can fold that import block to completely ignore it. Code generation is another problem, of course. I mean, if you generate code, it means you don't care about that code. You are generating complexity into your software, and that complexity lies there, lurks to be exposed through exceptions and bugs and so on, but you don't see it because it's like generated. Nobody cares. Then libraries also bring their own complexities. Not all libraries are equally complex. You should strive for simpler ones if you can. And this complexity is supported by dependency management tools like Maven or Nugget or Gem, whatever your favorite platform is, Gradle and so on. You just do a Gem install or Maven install, and you pull half of the internet into your project, and suddenly your deployment artifact has become 200 megabytes in size, although it's a calculator, and you have no idea why. So you have all this immense complexity that has nothing to do with your problem domain, and it's still there, and it may bite you one day. So be aware of the tools you use. These are good tools, by the way. Just you should be aware that they may yield complexity without you noticing. Frameworks is a separate topic. It's a favorite of mine. A framework is a library, but there is a crucial difference. When you call a library, you call it. When you have a framework, the framework calls you. So the framework says, I have a solution to your problem. All you have to do is fill in the blanks, right? So I have this framework, and there are some things I could not implement because I don't know your problem domain. So just put your problem domain into these blanks. And frameworks are, by definition, less flexible and more complex than libraries, for example. And I'm talking about web frameworks and innovation of control frameworks, persistence frameworks, and in particular, object relational mapping frameworks, which are immensely complex. Who here is using an ORM framework? Okay, half of the people. I would think that more of you were using. Well, if only half, I'm very happy. Who is happy about the ORM framework? Some people are happy, which is fair enough. It depends on how you use it, but if you let this ORM complexity leak through the persistence layer into your application layer, however you call it, domain layer, and God forgive the presentation, you have complected all of your architectural layers by just using the framework. I mean, it's completely complected in all possible ways. It complicates things like caching, session management, transaction management. You cannot reason about it. What happens when you have an entity and you set a field to a new value? Is that a query? When does it happen? Does it happen at all? Is it cached? Is it not cached? What if that field is another entity? What if it's a collection of entities? What happens? I have no idea. I work in object-oriented code, and underneath is all this complexity that's hidden from me. There's no transparency. And where there's no transparency, bugs lurk. So it matters because all abstractions are leaky. It's the law. ORM abstraction, as well as others, leak their implementation details from time to time, and you have to understand exactly what happens, exactly how they work. If they are opaque, you will have a problem. If they are transparent, you will have less of a headache trying to debug it. Okay, last, there's the complexity of the programming language, which is the least of a problem because you can always work around it. If your language favors inheritance-based design, then you are more likely to follow this pattern, which yields more complexity. If your programming language does not constrain mutability, you'll have to do it by yourself, which is also a problem. It's hard to do in a language which does not constrain mutability. And by the way, these are the popular programming languages fall into this category, like C#, Java, Groovy, Ruby, many others. And if your language lacks expressivity, it's less of a problem for complexity, but it sucks in general, so I just put it there. Now, how do we make things simple? This is a great tool, TDD, BDD, and refactoring. It's a tool to achieve simplicity among other things. Because when you're doing TDD, you're separating the role of a tester and the role of a developer. A tester becomes the designer, essentially. And so you will, more likely than not, have something that's minimal, something that contains less duplication, something that contains separate responsibilities and less dependencies. So TDD helps. Then you can be modular. It's also one of the better means to keep simplicity. Now, but there's a catch. I wish it was a little bit, okay, whatever. Let's do a vote. Who thinks the first elephant, the elephant on the left, is simpler than the one on the right? Raise their hands. Okay, I cannot see exactly how many, but yeah, about left is this side. So element on the left, more simple. Okay, about 15 people. Who thinks elephant on the right is more simple? About the same show of hands. Interesting. Okay, so the answer is elephant on the right is more simple. Why? Well, this looks modular, right? There are modules. I have an elephant and I have split it into modules, and now I have a modular elephant. Well, what do you do with those modules? Can you take any module, extract it, and use it in some other context? I mean, you can't really. Each module is designed exactly to fit in that precise spot where it can interact in some very intricate way with the surrounding modules. So it's not really modular. It just pretends to be modular. Now, on the right, can you take those modules, building blocks, out and recombine them in some other way? Sure you can. I mean, it's Lego blocks. Like this trunk, it's not really a trunk. It's a concatenation of little things which can be used for anything that's pipe-like. These legs are not really legs. They are made of simple blocks which can be recombined to build, I don't know, a house or something. So that's modular. That's not modular. Next thing, if you are interested in functional programming, and I think you should be interested, functional programming sports this idea of using values instead of state and pure functions instead of methods. So a value is something that does not change state. A value is $100, right? It represents itself. You don't go ahead and like, I have $100, but tomorrow I'll have 200, so I'll just, you know, strip this one and put a 2 in there. No, it's a value, it doesn't change. A pure function is something that takes a value and returns a value and does not have side effects, thus it's pure. If you program entirely in values in pure functions, you will have no state at all. And having no state will yield enormous simplicity in your system. But it takes a certain amount of, well, courage, for one thing, and then practice. We have adopted a functional language recently in Invente, and it completely changed the way we think about state management. I mean, mutable state inside our program. It also made the code base a lot smaller. Of course, there is, you know, some languages are better at supporting immutable things. For example, lists of things, like a to-do list. A to-do list is just a list, and if you want to remove an item from it, what you do? In an OO language, you just remove an item. You have a reference to a list and you remove an item. Well, that's mutation. If you are in a functional world, what you do is create a new list which has one item removed. But the old one, like a snapshot in time, stayed just the same. So you are still working with values, not mutable objects. It can be done in OO languages as well, but it requires certain discipline and library support as well. Okay, I have a little bit, 10 minutes, okay. Good. You should minimize your direct dependencies, of course. You should follow the law of Demeter, which says if A needs something from C, it should ask B to give that something if B has a connection to C. So if this on the top needs something from this one, it does not directly call it. It calls it via this thing. It's an indirection. Indirection is a good thing. It reduces dependencies and thus reduces complications and complexity. Single responsibility principle, you know it probably. It says that each component should change only for one reason, hence it has only one responsibility. And if all the components are singly responsible for one simple thing, they can be combined to achieve more complex things. Like in this Unix shell example, each of the Unix tools is simple in its own right, wget and tr and sort and unique, but they can be combined to achieve something more complex, like listing all the unique words in alphabetical order that are used in a certain web resource. So that's a complex task, but it can be achieved simply by combining simple tools. In this case, imagine these are simple objects, simple functions, or simple classes. Okay, when you design, try to be ignorant and oblivious. When you call someone, don't try to know exactly how that something is going to operate. Only depend on its external contract. Also, you should not know where it is or when it's going to respond if it's in a synchronous system. You should not care. The less you care, the less you imagine that you're in this isolated bubble and the world around this bubble is a complete mystery, you will have a good design. Design is about being ignorant. Well, that's not a very, don't quote that, okay? Also, choose libraries wisely. Of course, this is a quote from Stack Overflow, an accepted answer, by the way. The question was, do you use Camel or Spring integration? And one answer was, we chose Camel because the Fluent API is really nice. Okay. Well, that's not a particularly good reason to choose one library over the other. It's just programmer convenience. And we as programmers tend to choose tools which are convenient to use for some time, which look nice in demos, right? I don't have anything against Camel, by the way, just that this argumentation is really faulty. And prefer libraries if you can over frameworks. In the ORM case, there are not object mapping, but query mapping frameworks, libraries, and query builders, which perform not the same, but a similar task of mapping your, structure to query, but they do not care the overhead of object relational state persistence. And libraries are like a la carte menu when you come in and say, okay, I want you to give me some salad with these ingredients. I want you to put this kind of sauce, some mayonnaise, and I don't know, cheese, some ham. You have to know what you're doing when you are using a library like that, because you can pick and choose between different components. So it's a little bit harder, But in the end, you will have a simpler system if it's not complected. You know, if it's not a framework that says do it this way, and if you need to change something, you need to hack. And lastly, some of these things I talked about will probably require you to step out of your comfort zone if you haven't already, because we all have our golden hammers. You know, I invested so much time learning this framework or this tool, and now I'll use it for every problem that I see. You know? So if all you have is a hammer, all problems look like a nail. You probably heard this said before. So just for a moment, imagine you don't have a golden hammer. Imagine you're learning from scratch. What tools would you use? Just keep these advices in mind that I gave before when you're building your software. Make it simple, make it decoupled, make it isolated in responsibilities, and please reduce the amount of state that you use. You don't need that much state. And it was meant to provoke a discussion, so either now or after the presentation, you just can catch me when you like, and we'll talk about these things. Because 30 minutes is a little bit a big time constraint for such a topic. Any questions now?
A question about library usage. You said that if we use libraries, that in the end we will reduce the complexity. But if the framework forces how the library should be used, for example. So there are many ways how to use the library, and if there are many developers, they may decide to use the library different way. In the end, we will have bigger complexity.
Why do you think you will have a bigger complexity?
Because if different people will choose different ways to use the library.
Well, what you're talking about is the communication inside your team. I mean, even if you use a framework has certain like recipes how you can do things. If it's not completely restrictive framework, you still have to come together and decide how you are going to build stuff. In that regard, I don't really buy that you will have more complexity just because you did not. Well, you should be talking with your developers. If you are 3 people in a project and they are all using the same library or the same framework, it's the same problem. I mean, I don't see a big difference.
Yes, if you have 3 people, if you have 300 people working in separate cells, right, and developing the different part of the elephant we saw, and they all use the same library, but the communication is not happening across our cells that, okay, let's use this library for this in this way. So
the problem is
different cells may decide to use the library different way, and in the end, we will have different ways, and maybe one way is not so good. So the framework actually forces you to have one way how to use it. So what do you think about it?
I think if you have a distributed team and each sub-team in that team has its own way of using that library or something like, it's okay. Each team will yield something that is simple, so the integration must be made simple. It's okay if they have different requirements the way they use this library. You don't have to force everyone into the same constraints. And in general, if you have a 300 people team, you have a problem. I don't care if you're using...
It's a company, for example, working in the separate cells.
Yeah.
So 300 people working on the different parts of the elephant.
Okay.
So they develop their part of the project.
Okay. I mean, why do you want to enforce all of those teams to the same kind of constraints? It's okay if they use their own environment and their own constraints and their own libraries and their own style of working, so long as they produce a subcomponent which is simple in its own right. It can be composed with other components, it will just work. You don't have to enforce those rules. That's my point. If you use a framework, all you win is that everyone more or less works in the same style, but why do you need that? What does it give you?
Another question would be, what about solving the same problem with 10 set of tools, 10 set of libraries, like good practices whatsoever? I mean, you can use any library to solve a single particular problem, and like there's a chance actually somebody will use different tools to solve different libraries, and you end up like using 10 libraries to unzip the single file. Yeah, or calculate the difference. It's so many tools, and somebody choose the different one.
I'm not sure I get the question. Your question is what happens when you use too many libraries?
I mean, for particular problem, you can use many libraries to solve it. And when you have a huge team.
Oh, so you have a choice, many choices.
Yeah,
okay.
and what you end up, it's like you are using 10 tools to solve a very same problem.
Well, I believe in one team you will just use one tool if the team agrees on which tool they want to use. In another team you may use another tool, and it's okay. I mean, if a question is that okay? Yeah, I think I don't see a problem with that.
An extra complexity.
Complexity in the sense that I just discussed it's not a complexity. Complexity would be if you would all use the same tool and would try to adapt that tool to your particular needs. That would yield more complexity. If you choose a particular tool and you say it does exactly what I need because it's small and it doesn't do anything else, it's less complex. And if you choose 3 such tools which do certain different things, you combine them, it's still less complex if you keep the dependencies separated, decoupled.
But somehow you forget that you can fully test one tool, but you can't fully test a full environment. You agree that a lot of frameworks solve the very same problem, but they have their own unique problems.
Yeah.
You can never be sure about that. This is an extra complexity you don't want to have. Like, you have a tool to unzip file. That's easy, But there are so many unzippers all around the world, and I guarantee that most of them have a ton of bugs. And you use multiple of them, so what's the chance of bug to encounter while you're using it? Use 10 libraries instead of one.
It's right. I mean, the more code you use from a third party, the more likely you will find a bug in that code.
So there's the balance.
Maybe you can discuss about this during lunch. And last question from Raymond.
I was Rich Hickey's talk, so at Ruby conference where he kind of tried to tell that functional languages are simpler than object-oriented languages, but what I have seen that quite often it's just where you shift this complexity in object-oriented languages, so probably you have a more complex object structure, but simpler messages flowing between these objects, simpler data. In functional languages, so I see that, okay, maybe you have simpler functions, but you have more complex data structures traveling around these functions. So isn't it just your preference, so where you want to put your complexity in object structures or data structures? And so there is no one true answer.
I see it as orthogonal concerns, the way you model your data and the way you model the algorithms behind that data. You can have complexity in both, and you can have complexity in neither. If you separate dependencies and follow the law of Demeter and other practices, I mean, it's doable. We use a functional language. I wouldn't say we have very complex data structures. Well, it's true. It's a different kind of coding. In the end, that wasn't the point of my presentation. The point was to to mention functional programming in general, because too few people are familiar, but then to say that it solves one particular problem well, and that's state management. It reduces the amount of states, and if nothing else, you should just try it for that.
Okay, thank you for your questions. Thank you for presentation. And sorry for technical problems. And now we're all going for lunch. This will be in